So this is we're gonna explore the absolute value or modulus of a function. Absolute value there is that's how you represent it. It's two vertical lines inside with whatever you're trying to find the absolute value of in the inside. But what you're probably taught in elementary school is absolute value of 5 is 5. It's without regard to sign. And so the absolute value of -5 is also 5. So there's no regard to sign. What we're going to concentrate on is the second part of this, which is distance from 0. So it can also be thought of as distance on a number line from 0 in its most basic form. And in the examples below here, I'm going to kind of look at all of these examples, and I kind of have them set up from simple to kind of complex out here. Here's your complex example. So here we go. Just a quick review of distance. Distance tells the number of units between two numbers it's the number of units between two numbers without regard to sign. Blah blah. Distance is referred to as a scalar quantity. So if you have -3 and -4, if you graph those, so here's -3 and here's 4, you can just count the distances. There's 1, 2, 3, 4, 5, 6, 7. So my distance is 7 from -3 to +4. But you can also think about that as the absolute value if you subtract them. If you take -3 minus 4 and take the absolute value of that, that would be, -3 minus 4 is -7, and the absolute value of that is 7. It's without regard to sign. So, and we'll get into, so that's kind of the first definition. And it doesn't matter if you want to find the distance of something, you just subtract it. So 4 minus a -3, it doesn't matter what direction you subtract it. 4 minus -3, remember minus minus is plus a positive, so that'd be 7. Absolute value of 7 is 7. So the distance is 7, and there we've kind of used the first part of the definition to figure that out. So now let's take a look at just the absolute value of -3 with respect to distance. So absolute value of -3, we could rewrite that as the distance between -3 and 0. So I have it here, the distance between -3 and 0. So you can we assume that there is a 0 in there. If you think about it as distance. Now the distance from -3 to 0, again, if you just count it, 1, 2, 3. So that distance is 3. Same with 2. So if you did 2, the absolute value of 2, the distance from 2 and 0 is 2. So, here's 2. You've got 1, 2. Distance goes away from 0. And so you can also use the second part of the definition of absolute value here. And so the absolute value of 2 is really, we assume there's a 0 in there, and it's 2 minus 0 because the distance is 2 away. So that kind of goes beyond. So now let's take a look at this problem. So you got the absolute value of x equals 4. So now I think it's a benefit to really use that distance definition. So we could go ahead and say the distance from x and 0 is equal to 4. So that literally translates to this. So the distance between x and 0 equals 4. So here's 0, and the distance between x and 0 is 4. Well, 4 units away would be here at 4, and then also -4. And so your distance is 4 away from 0 in both directions. And so your answer to this would be both 4 and -4. So those are both 4 units away from 0. So also if you plug that in, the absolute value of 4, kind of crazy, pin's working weird. Absolute value of 4 is 4, and the absolute value of -4 is +4. So you can also use the first part of the definition and just take the sign away. So that's how it matches in both cases. So this one, it says the absolute value of x is -2. Well, in this case, absolute value is saying the distance between x and 0, so distance between x and 0 is -2. Well, distance has no sign. It doesn't have a direction. Distance is neither left nor right. So in this case, this is no solution. You can't have a distance of -2. And so this one's kind of a trick question, but it gets right at the heart of an absolute value. And it's basically saying if you try to plug 2 into that, absolute value of 2, well, if you take the sign away from 2, it's not -2. So those cannot be equal. And so you can use both sides of the definition on this. But in this case, if you think about it in terms of distance, distance is neither left nor right, up nor down. Distance is just a length, a scalar number, and so no solution. All right, so the distance, so in this case, we've got the absolute value of x minus 3 equals -4. So at this point, maybe pause the video, see if you can find the answer to this based on what we've been doing so far. But I'm going to just show it to you. So the main thing is how does it translate? Well, it translates to this. The distance between x and 3 is 4. And so you can kind of put this in straight into your number line. So if the distance between x and 3 is 4, because now it's not a 0, because we actually have a number there. So we're subtracting x and 3 to make 4. So the distance between x and 3 is 4. So we'd have 3. So here's 3. Whoops, I hit the wrong button. So here's 3 right here. And the distance between x and 3 is 4. So 4 units is to x. 1, 2, 3, 4. So here would be 7. Is 4 units away from 3. And then another one that's 4 units away from 3, if you go the other way, is -1. So our two answers are -1 and 7. And you could plug that in and make that work. So if you wanted absolute value of -1 minus 3, well, that's the absolute value of -4. You take the sign away, and that's just 4. So that's true. So that checks out. Now let's check out 7. Well, 7 minus 3, the absolute value of that is 4. The absolute value of 4 is +4. If you take the sign away, it checks out. So both answers are correct in that case. And a lot of times when I used to teach this, I used to just say, well, x minus 3 is equal to 4, or x minus 3 is equal to -4, and solve both of those. However, that doesn't make a whole lot of sense based on the definition. It's just an algorithm that works. Now, we can make it make sense and play around with it a little bit, but it's better to look at it in terms of distance. The distance between x and 3 is 4. That makes a lot more sense in terms of the definition and mathematically. And so this one's just a little trickier because you think about it, it has x plus 2 in here. And so you have to think about distance. Well, distance, you always subtract the numbers. So you have to think about, well, how would I subtract those two things and make it positive? And well, the answer to that is you would make it negative. So the distance between x and -2 is 5. And so what that would look like then would be this. Whoops, not like that. I moved it on you again. It looks like this. It would be x, the absolute value of x minus a -2 equals 5. So in other words, anytime you want distance, you have to subtract the two numbers. Well, if you subtract two numbers, that's really, plus a positive 2. You got two changes in direction. And so that's how it's back to a positive. So it uses that distance again. But more importantly is this part. The distance between x and negative 2 is 5. So if you find negative 2, here it is, and 5 units away, so 1, 2, 3, 4, 5 would be 3, and then 5 units the other way. Let me change colors from negative 2. 1, 2, 3, 5 is negative 7. So in that case, there's our two answers. So if we plug those in, so negative 3 plus 2, let's see, or positive 3. It's positive 3 here. I was going to do negative 7. So positive 3 plus 2, the absolute value of that is 5. You take the sign away, that's 5. That's good. And if you do negative 7 plus 2, plugging it in here, the absolute value of that is also negative 5, which is also, if you take the sign away, positive 5. So both of them check out. And again, back when I was teaching this for the first time, I would have done something like this. Well, x plus 2 equals 5, or x plus 2 equals negative 5. And again, that's somewhat confusing with the whole definition of an absolute value. That works, that algorithm works, but to me, this just makes so much more sense to convert it into distance. So now let's take a look at two more examples. And again, see if you can use that distance to figure this out. Maybe pause the video before I just start explaining it. But here we go. So if you have this thing, I don't have a number in here. Whoops, hit the button. So it's the absolute value of x is greater than or equal to 3. And so what we're going to do here with this thing is plug it into the distance. Well, if you do that, here's what you'd have. So the distance between x and 0 is greater than or equal to 3. So in other words, we have to think about this thing as a distance. So we don't have a number, so we'll assume it's 0. And so we'll change it to that first. And that's how you get this, the distance is from 0 is greater than or equal to 3. So the distance between x and 0 has to be more than 3. Well, that would be right here at positive 3. And it has to be greater than or equal to, so it'd be all the values there or above. And the distance has to be greater than 3, which means it could also be from here and below. Yeah. So the distance from 0, because here's 0, is more than 3 away in both directions. So you've really got two answers here. So either x is less than or equal to negative 3, or x is greater than or equal to positive 3. And that's how I would look at this. And so if you look at this next one, absolute value of x is less than 4, again, same deal. X minus 0 is less than 4. And so that is saying the distance, let me pull it up here, so I'll put it down here on the bottom. The distance between x and 0 is less than 4. And so here's your 0. Whoops, clicked on the wrong thing again. Here's your 0. And if it has to be, the distance has to be less than 4. Well, from 0. So here's your 4. So we wouldn't include 4, so it'd be an open circle. And it'd be all the points here are less than 4 away. And here's negative 4, again open circle, and all the points this way are less than 4 away from 0. And so your answer in this case is from negative 4 to positive 4, x is sandwiched in between them. So x is greater than negative 4, but at the same time less than 4. And so you could also say this. You could say x is greater than negative 4 and x is less than 4. So that'd be another way to write it. And there's a few other ways to write it. But essentially, getting the meaning of this, it's in between those two values, between negative 4 and positive 4. And that's good enough. And no talk about absolutes is complete until you talk about the absolute value being greater than a negative 3 and the absolute value being less than a negative 3. So if we use our definition again, here would be the left one. The distance between x and 0 is greater than negative 3. So if you logic that out, even though you can't have a negative number with distance, since distance is always positive, all numbers would be greater than or equal to negative 3. So in this case, all real numbers that you would plug in here would be true. So all the numbers along this axis would work. Everything from left to right. And then on the right side, it says the distance between x and 0 is less than or equal to negative 3. Well, the number is less than negative 3. You know, here's negative 3. All of these numbers this way would be less than negative 3. And so they're all negative numbers. Well, distance can't be negative. So in this case, it's no solution. The empty set. And again, over here, it's all real numbers. So all real. So those are kind of the two weird ones. My mouse is not working. There we go. Wow, that's really sloppy. But that's all real numbers. And so now we're ramping this up a little bit, more complexity. And if you have the absolute value of x minus 4 is greater than 5, again, if we wanted to use the distance definition, there it is. The distance between x and 4 is greater than 5. So we're finding the distance between x and 4 because we're subtracting them. And it has to be greater than 5. So if you plug that thing in, and here's 4. Whoops. Keep doing that. Here's 4. And the distance is greater than 5 from there. So 1, 2, 3, 4, 5. There's 9. And it's greater than, so it's open circle. And all of these numbers are greater than 5 units away from 4. And then if you go the other way, do it in green. 1, 2, 3, 4, 5. There's negative 1. Again, it's greater than. So all of these units have a distance of 5 units, more than 5 units away from 5. And so this one would be either x is greater than 9 or x is less than 1. So there's your answer for that one. So if you move over to this one again, x plus the absolute value of x plus 2 is less than or equal to 3. And again, you need to think about distance. So, anytime you have distance, it's actually you're going to subtract the two numbers. So to make it positive, it has to be minus a negative. So you'd have to rewrite this to think of it in terms of finding the distance between 2 points. And so that's how you'd rewrite that. And the definition then of that would be the distance between x and negative 2 is less than or equal to 3. So here's negative 2. Oops. Keep doing that. Here's negative 2. And the distance has to be less than or equal to 3 away from there. So there's 1, 2, 3. Right there would be a solid circle. And then you'd also have 3 the other direction. So 1, 2, 3, we're here. And so it's all the points from negative 5 to 1. Those are 3 units away from negative 2. And so you just say something like this. So negative 5 is less than or equal to x, which is less than or equal to 1. And that's how you get that one. And now we're to the final problem, which is about as complicated as these get in like an Algebra 1 or maybe even an Algebra 2 course. But what you want to do is kind of get rid of the complexity. You want to just solve this equation for the absolute value. You can't distribute through an absolute value. That's kind of a complex gadget there, finding the distance between x and 3. And so we're going to take the complexity away from this. And so I would subtract 5 from both sides. And so now you have 2 is the absolute value of x minus 3 times the absolute value of x minus 3 is less than or equal to 8. And then this is multiplication, so then you divide by 2 on both sides. And so the absolute value of x minus 3 is less than or equal to, I forgot that, 4. And so now you can go ahead and do your distance thing with this. So in this case, the distance between x and 3 is less than or equal to 4. So less than or equal to 4. If you can read my chicken scratchings there. And so if you do that, so if you have here's your 3, and so we want all the distances that are less than or equal to 4 from there. So that'd be 7. That's 4 units. And then if you go back, that's negative 1. That's 4 units away. And so it's all the points between those two are less than 4 units away from 3. And so when you do this solution, it's negative 1, less than or equal to x, less than or equal to 7. So this one's probably one I'll redo in the future, but I kind of like how this, I like the concept. I apologize for the sloppiness. I'm kind of getting used to some new equipment. But I hope this helps, and I hope you actually understand this rather than just follow an algorithm blindly, and use the definitions that are given to you to figure this stuff out. You'll be way further ahead mathematically. So thanks a bunch, and see you next time.